Hi, I'm Andy Gray, co-founder, CEO, and CTO of Kortical, and today what we're going to be talking about is going from raw data to live machine learning app that automates bookkeeping in about 30 minutes. Now, while we're going to be talking about bookkeeping, this could be applied to any process where we have digital data coming in, some repetitive work that's being done by people, and then digital data going out. For this example, we're actually going to look at our live accounts, cleaned up obviously, because we don't want to leak any sensitive data, coming out of Xero. Then typically we'd have an accountant who'd have to go through all of the rows, looking at all the amounts, all the descriptions, and then classifying them into sort of, entertainment or into audit and accountancy fees. And basically by doing that, they're helping us basically understand what we'd have to do with our tax, as well as this basically how we do operate from a company management perspective. So while this is something that requires expertise, it's something that can be really repetitive. So basically, we want to help the accountant not have to go through every single row themselves, and we want to automate 90 to 95% of the work and let them just sort of supervise the rest of it. So what we're going to do is we're going to build a Kortical machine learning model, and then we're basically going to use that to automate the bulk of the work, and then they're just going to be able to do the training and management on top of that. So before we dive in, some of you may be asking, what is Kortical? Kortical is an AI platform to rapidly scale the delivery of superhuman performing enterprise-grade AI and ML solutions with UI and code interfaces. And this is basically helping you go from raw data to live production enterprise-grade machine learning solution fast. It covers everything from exploratory data analysis, data cleaning, feature engineering, model creation, explainability and reporting, app and service creation, DevOps, MLOps, and infrastructure. Basically that whole infrastructure layer going underneath all of those processes. Kortical is used in a wide range of applications. With Deloitte, we're looking at accounting automation, which involves a lot of NLP. With NHS, there's supply chain optimization, which is time series for demand planning. With Charlotte Tilbury, we're looking at marketing optimization, which is really all around personalization and giving people the absolute best experience. And that's just a couple of cherry-picked examples. There's so much more. Okay, so let's dive in and start looking at where we're going to get this bookkeeping data from. So we can go into Xero, we can go to the accounting tab, reports, and then we can go into the detailed account transactions. And then once we do that, we should end up with a file that looks something like this. So here we've got the account code, the account name, the date, the type of the transaction details, then the reference, the gross, and a whole load of VAT details and some other columns. So we can already see that we're going to have to do some data prep because this is obviously the final data that we have right at the end. Okay, so when we're looking at sort of like the sequence of what really happens, we at the start you end up with the transaction details. We've got the who, the account name, we got the why, what the description is. Now Xero tends to put those two things together, and then basically what the accountant is helping us determine is basically the account code, the account name, also that VAT classification, which gave us all of those VAT columns. So to simulate the data as it comes in, we're going to have to remove all of the columns except for the account name, the date, the transaction reference, and the gross, and we're also going to have to remove those manual journal entries. All right, so let's do that now. Just copy this. Okay. Import pandas, and then we need to load our data frame. Great, so now we're going to need to drop those manual journal entries, and they were in the type column, and so we want to say where it's not equal to MJ manual journal. Alrighty, and then we just want to keep those columns which are, salient. Just gotta put that in some brackets. We also have that reference from the bank, and then we've got the gross. Okay. So now we've got that done, and then we want to save that out to a CSV. And we'll just put that into the same place, but we'll call this one processed. All right, and we're just going to get rid of that index. Oh. Great. So now if I run this, we should get our new data set. So let's check that out. Great. So now we've got the data we need. The next stage is to start to build the app, get the test and training split, load into the platform, create the model. So let's get started. To create an app, we're just going to follow along with the instructions that we can find in the documentation. So this basically covers off absolutely everything you need to do from installing the Kortical package through to setting up the config and all of that sort of stuff. But hopefully I can remember all the instructions. Okay, so let's create that app. So Kortical app create. Well, maybe if I could spell, Kortical app bookkeeping. So here we've got a number of different templates. So if we're trying to build different types of applications, websites or database updating or all that sort of stuff. But here we're looking at an automation template because this is an automation task. So this has basically created us a nice bookkeeping app, and we're just going to dive into that right now. Okay, so as we look into the folder structure it's created, we've got the .github folder, which is basically, this is a complete app, so we basically have all of the continuous integration hooks all in here. We've got a data folder, which has a demo data set in here to kind of let you kind of run it out of the box, but we're going to update that to point at bookkeeping. And then we've got the Docker and Kubernetes folders. So obviously, this is completely based on open source technology, so you can run this anywhere, but with our commands like Kortical app deploy and everything, we make this super simple. So you don't really have to worry about that unless you want to. Then we have the local scripts. So we've created some local scripts to basically do things like split out the training test data and adopt models and stuff, and we're going to get into that in a little bit. And then we actually have the source for our package. So this is kind of like where the meat and potatoes of this sort of web service is going to happen. So obviously, when you create a model by itself isn't always that useful. So it's basically you want to surround that in an app, and that's what these app templates help you do. They help you kind of build that app really fast and get going. So then we have the API for the apps. This basically sort of, consists of a number of endpoints. So basically we register these different routes to do different things like doing training and doing predictions. So obviously if you've got new data, you want to retrain a model, if you want to get predictions out for the model, these can then be hooked into workflow services, or what we're going to show you right now is we're going to show you basically when we do it as like through the UI that this has as well. And basically here, we've got this UI, so we've got a really simple UI, but you can extend it to do whatever you want. And then we have these workflows which kind of underpin all of this sort of stuff. So again, we have that sort of train workflow, we've got this predict workflow, and as part of training, what we're doing is, because it's not only about training a model, but we're going to go through this in a little bit more detail. But then what we got to do is we got to use this superhuman calibration to find the subset of data on which the model can perform at superhuman level. Because basically we create a model, it's not necessarily going to be, across the board able to do things as good as a human. So we need to be able to basically tune down and figure out what parts of the data it can really do that well. And then we need to refine those thresholds so that we're always going to basically make sure that we're going to hit at least that quality mark to maintain that human level or above. And then for those records that it says it can't automate because it's not confident on, then those need to be spat out to that human accountant who can then look at those edge cases or those new data or those types of things and basically feed that back into the system to act as new training data. So it just keeps on getting smarter over time and keeps on improving. And also we just keep the quality of predictions super high as well. Okay, so let's dive into how we set this up. Oh yeah, and one more thing is that we've also got the tests. So basically out of the box, you've got a full test suite, basically, integration tests, unit tests, all that sort of stuff. So you're really ready to go. So the first thing we want to do is basically set up some of this config a little bit. And so basically if you just edit the config, you can really quickly set up your app, and obviously you can kind of get into editing the code and doing all that sort of stuff if you want to do, really customize it a lot more. So we're just going to go over here and we're going to get the system URL. So we're going to paste that in here. Then basically it's asking us for the data. So this is set up for the animal shelter CSV, which is the demo, but obviously we want to use our bookkeeping data. So we're going to get our transactions process that we just created, and we're going to put this into this folder. And then hopefully in a couple of seconds, bam, that's appeared just there. Right, so then we want to get the path name to this. Okay, we got the file name. And then we paste it in here. And so then basically, everywhere where this uses data, We also, like, it's going to just basically now access this file instead of the other file. So, that's going to be good for us. So we might as well just change the API key as well. So this is basically how we can make sure that nobody else is going to access our app pretty simply. Obviously, there's sort of more complex options. So basically, we got this good here. So let's just generate a new good. Right. And then we can just paste this in here, and then that's going to be unique to this app, obviously. So it's already pre-filled this in with the name Bookkeeping. We're trying to predict the account name. So that's basically that first stage of that accounting workflow. And let's say we want to basically hit a 97% automation. So that should basically hopefully give us something that's really sort of, strong at least human level, if not above. And then basically, if it's not going to be automated, so what's the class that we're going to use? We're going to have to introduce a new class to the model in the cases where it can't automate things. So we're going to call that not automated. Cool. So with that set up, now we're going to get our training and test data. And what this is doing is basically we've got this common code here, which does the create, train, calibrate, and test data set split. And if we have a look at this code, this is just sort of like some really simple code about sort of saying, right, well, let's split the data set. So, 33% is going to go into our test set. We're going to split our test set up in 0.5 for the calibration data. So when we're looking at that superhuman calibration fitting, we do that on the calibration side, and then we can test it on that held back test set. So there's at least some data that we never involve in any part of the training process. And basically the reason why we're going to do it through the platform first is because this just means that when we go to do the sort of to applying the thresholds, it's going to look to split the data in the same way. We're going to be able to use that same test set. And then basically when we're looking at the retraining pipeline, it's just going to go through the same pipeline as well. Alrighty, so let's run the get train and test split. Okay, so that's run now. And now we can see that these test set and this train set have appeared here. Cool. All right. So now we can go to the platform and load this up. Okay. So we're going to dive in here, add data set, add our new train data set. Great. So now we can basically see the data set in the platform, and we're ready to start looking at this from a real sort of machine learning point of view now. So the first thing first is we want to select our target. So we're looking, this is account name that we're trying to predict. So we're going to set this as our target. And what we can see here is that there are some classes like travel and subsistence, which appear like a lot, and then it trails off a lot towards the end. So as we're trailing off towards the end, we're going to notice that, it's not going to be that accurate at predicting those, because obviously if you've only got a small subset, it's not going to be able to learn that much about the descriptions. So we're not expecting the base model to be crazy good, but this is where the sort of human can come in and basically keep on adding examples to those ones until we get enough data. Now obviously if we were like a super large organization, then maybe we'd have like 1 million of each examples, but this is sort of like how we can get going for like a small medium-sized business like ourselves. So now we basically selected that, and the first thing that we generally want to do is we want to do some exploratory data analysis. So this is basically where we will work to try to understand the data, understand how the machine learning might understand the data, and this gives us sort of like insights. So when we want to try to modify the data, we can kind of like be going from a position of strength here. So one of the first things you might notice is we start building up these ensembles. And this is going to give us a really great way to rank all of the features, even ahead of actually having built some models. So we're going to get some good insights into which features are the most important, which ones are providing the most value, and then we can start to use that to sort of look at the feature engineering. So basically, one of the things we can notice straight away is that most of the columns are completely filled in, which is good. Reference data, though, we are missing about like 40% of the values. But that's not really that surprising for a reference from a bank. It's not always filled in, so that's absolutely fine. We're seeing the columns are all green, which is telling us there's a really nice mix of values in the columns, so that's looking really good. And then this is where we're seeing that sort of like ranked features. So it's showing us the most important feature first, which is the transaction text. And that's really good, because if we're basically saying that the accountant's supposed to look at the description, figure out what it is, it's good that it's saying that this is the most predictive thing. So it's not that we've got some other sort of like leaking variable in there, which is good to know. When we're looking at this, we can see, look, if Uber's in the transaction, then that's a good sign that it's travel. That makes sense. If it's got Barclays in there, it's bank fees. Basically, if we're looking over here, marketing tools, if it's got HubSpot in there. So that's all making a lot of sense. And this chart is basically showing us the top 10 most predictive words. So just giving us a real feel for sort of how we're understanding that data. So that's really cool. And then we can see that sort of gross is the next one. So, and if we're looking at the features, obviously transaction there is massively ahead in terms of the feature importances. But gross is sort of pretty good. So if we take that out, we can see, okay, this is coming through as text, and then we can see that these are strings. So, we might want to take a look at that as well. So coming back into this view, we can start to see that, look, we know that Xero basically puts the who, so, team sport and client entertainment in here. So basically we want to spit out the who and the description, and basically see if that's going to help us sort of, even though Xero merged those, maybe if we unmerge those, that'll be, more help from a data science perspective. So the first thing to note here is that we give you this code access to the Kortical platform. So basically you can do the sort of, transform and fit. So obviously fit is where you sort of do all the modeling and all the data that you'd have in train time, and then basically you can store off some of the data to then use in the transforms at predict time. But for this example, we're just going to need to change up what's happening at predict time, and obviously both, but we don't need to worry about fitting because it's just a very simple transform. So basically, for this lets us say, okay, what are the input columns? So the input column is transaction. What are the output columns? So currently it's transaction, and we're outputting it as text. So we're like, if we then do this transform, we're going to overwrite the original column. So I'm going to change this column name up to who, so that we're now adding a new column. And basically, if I wanted to remove the original column, then I would tick that, and then I'd be able to sort of get rid of the original column. But now what we have to do is we have basically to kind of say split this out, so we don't know who is all of the bits before the dash. So we're going to do dot map lambda x dot split on the dash. Then we're going to do 0 and to get the first part, and then we're going to strip it to clean off any white space, and then we're going to check if the dash is inside x, because obviously we don't want to get the 0 if there's nothing in there, and then we can do else just x. So if it's just basically showing us if it's just showing us the name and there's no dash, then we just want to put the name in there. All right. So now we're basically going to make the output column match the input column. So we basically have who and who, and then it's telling me that I've got a syntax error. So let me just check this out. I forgot to put the in. All right. So basically, we're trying to figure out if that dash is inside X. So basically, that. So basically, we're going to now basically what it's doing is it's going to build up a whole bunch of models, and it's basically going to tell us basically that if this is better. So we can see that actually across sort of in the background it's building on linear models, XGBoost, deep neural networks, and we can see it's got to sort of 21.57%, which is pretty good. And I mean, that's a really nice improvement in this sort of univariate scoring. But one of the things is that maybe, understanding it as text is a bit more confusing, and maybe actually as categoricals, it can just split out who the different suppliers are a bit more. So let's try that with categorical now. And then we can basically see if this, gives us a nice improvement. So yeah, we got to beat that 21.57. And then we're going to see how we do. And I think one of the really cool things here is that, it's just the speed at which we can iterate. So usually if you're looking at a sort of, feature transformation pipeline, you're looking at something where you kind of do a bit of data cleaning, do a bit of feature engineering, then you got to do your model building, and you got to do all the bits in between. And then somewhere down the line, you end up with a score. And then you got to figure out how you attribute some of that score back to that feature engineering you did earlier on. And then you got to remember the context for all the feature engineering you were doing earlier on. Whereas here you can just sort of like in a tight loop really just iterate on these features to try to make them really good. So here we can see that we've increased it from 21.5 to 24.4. So that's a nice little win, and we will take that. Okay, so now we can go over to gross, and we saw that this is text. So if we look at the raw data, we can see this is because we've got these pound symbols in there, and maybe we want to treat it as text, so we don't want to just automatically change that up. But what we do have in here is, obviously we sort of showed you the code example where we're sort of going in and manually coding it up. But what we can do here as well is basically we've got all these standard transforms, like in the platform for the sort of like different sort of, types of data that you might be trying to do. So, if you want to do send analysis on text, or you want to do these things, you don't have to basically kind of figure them out every time. We've got a whole load of really nice examples in here that you can work from. So here we're going to look at currency to number, and we can just apply that. And so what this is doing is it's basically, going to replace out anything that isn't sort of between 0 and 9, doesn't have a minus or a dot. So we're going to strip out that pound sign, and then we're basically going to sort of that's obviously doing a string replacement, and then we're coercing it to be a numeric. Now, it's come out and told us that we're like 43% worse. So maybe you might be thinking, we don't want to do this. But actually the thing is that what we're doing here is we're overriding the original column. And for some columns, this is always going to make sense. But actually, when we think about what's going on with, a price, actually the thing is maybe sometimes someone fills out the description, but then maybe another time they forget to fill out the same description, but it goes like it's exactly the same price. So in that way, actually having it as that sort of text column where it can pick out exact tokens and be like, hey, this token is important, and we see this token repeated, that's really valuable. So what I've done now is I've changed the output column name to add an underscore numeric. So now, because I'm not removing the original column, we're going to have the original column and we're going to have this numeric column. And then we're going to see if maybe by adding this numeric column, we're actually going to, improve the scores overall, and then, get a better model out. One of the things, though, that we're going to have to watch out for, though, of course, is that these two features are going to be quite highly correlated, probably, because in how they refer. So, that's another thing that we're going to be considering. Obviously, two highly correlated features can actually reduce your score because they confuse the model rather than actually sort of helping to improve it. So now we can see we've gone from minus 43% to minus 17%. So that's a massive improvement, but it's still not a very good result. We're still making things worse. Now, when we actually kind of like look at this data right now, the first thing that's jumping out to me is that we've got a huge range in here. So we basically have like this column is basically like all around 0 and a slight bit of things that sort of like looks be about like, minus 25, plus 25, and then there's this huge extra range in there. So now we've kind of done this, but now we can actually combine this with one of our other code examples. So now we're going to say, hey, numeric, can we just clamp the range on this? And what happens if we clamp the range? Maybe, just maybe, we get a better model. All right, so let's try to basically chain these together. So we're basically taking the column from there, and then we're putting it into so we're basically taking our numeric column, and now we're just basically saying, right, rather than doing it on the original feature, let's do it on this column feature, and then we're going to say, okay, minus 25, 1, 2, 3, plus 25, 1, 2, 3. Okay, so that's minus 25,000 plus 25,000. If we clamp the range, what we should see is we should see this chart squash down, and then, maybe this is actually going to give us a slightly better score than last time. So what we're trying to see is can we actually make it positive? And obviously, if we're finding that actually, look, it's just the numeric representation just isn't that important and is confusing, then obviously we can just basically sort of just reset code, go back to what we originally had, and then sort of like we've learned like a nice lesson about sort of, well, actually this feature engineering, we sort of seems really obviously like it should lead to an improvement, is actually just not helping us to make the model better at all. And I think just another thing here is that sort of like what we've done is we've tried to find a set of algorithms and a set of parameters which train reasonably fast, but then also give us a good range of feedback. So obviously these scores are not sort of perfectly indicative of exactly what's going to happen when we build a larger model, but they should be very highly indicative. And then in most cases, when we see an improvement here, we're going to see an improvement there. And you can see by sort of like sticking with it and doing this feature engineering, it looks like we've got to sort of like plus 9%, which is a nice improvement to have. So we'll take that one as well. All right, cool. So now we kind of like, we've explored our data a little bit, we've kind of understood it, and now we're going to look at building our model. So we're just going to call this Kortical transactions processed, and then we're just going to create up this instance. So this is basically where we're going to step into the AutoML section. And this is where it's really going to try to, rather than building fast models which give us insights really quickly, it's going to try to build really, high-performing, very robust models, and it's going to take a bit more time. Alrighty, so I've upped that to 6 workers. So what that means is we're going to have 6 computers parallel in the cloud trying out different models, and then what's going to happen is it's going to go through and sort of try to figure out what sort of algorithm family is going to work best, what sort of data cleaning steps are going to work well, how should we be treating text, how should we be optimizing the hyperparameters, and it basically does this whole solution based search, which obviously is more parameters than atoms in the universe sort of thing. And the idea is basically what we kind of do in a special way is really try to find out that best solution really quickly, and that's where we have got really good results beating top providers like Google. So if we go down here, we've managed to build 2 models so far, and our best score is 0.44. So we basically kind of leave that training a bit longer. And what we can see is that basically, it's already picked out, it's already built up this model code for us, which basically is built off what we just did in the previous page, and when we're looking at the data stuff. And so it's basically kind of selected the F1 score, it's figured out its classification problem. If I basically sort of change up F1 score, I can see, I've got all these other metrics that I can use, but accuracy, log loss, all that sort of stuff. But for us, basically, F1 score makes sense. It's also basically detected that it's a time series algorithm. So you might have seen there was that sort of blue bar when we sort of open up the columns and we're saying, hey, this is your data index. So as soon as we include that data index, then it's basically automatically going to split the data to do the sort of the test and train based on the dates in there. So it's going to take the latest 20% as the test set, and then it's going to leave the rest to, as the training set back historically. And then when it's doing the cross validation, it does a cross validation through time, so it's never going to leak any data from the future during that training process. So we're always testing against data that the model's never seen, and then and then basically we come down and we can see the sort of the features. This is the numeric feature that we created, the gross numeric. We've got this categorical feature, which is that feature we created, which is the who. Then we can see the code that we use to create these columns is in here as well. So obviously these specifications kind of act as a full descriptor of everything that we've done and that we're going to do with the model. Now we can also see that we've got the different models that it's going to try down here. So we've got more models in the platform that are listed here, but these are the ones that we see that actually that win the competitions and produce the best model sometimes. So obviously, if we never see a model produce a good score, we're just not going to include it in the sort of solution search space to try to keep it, a pretty tight experience. Now, if I wanted to get in here, I could basically choose, reference, and I could basically say, I want you to create features that are, Word to Vec, and basically, I want to use a window, I gotta spell it right, that's between sort of range, let's say 2 to 4. And so basically, if I want to restrict what's going on in this page, I can really sort of get in there and control the solution that's created. And we think that's really important because, data scientists, you gone to a university, you've kind of learned a lot of stuff. So, we're just trying to give you something that basically accelerates you, but doesn't stop you from being able to kind of, add all of your knowledge and all of your value to produce the best solution. So typically what we do is we do quite a wide search to start with. And then as we're iterating, adding more data, adding more features, then we kind of like narrow down the model space. We kind of start to figure out what sort of parameters are working well, maybe get ideas about new ones that we want to try explicitly. And then we start kind of like expanding the spec out and kind of, working in that more sort of, manual way. So here we can see the sort of like, after a couple of models, what it's doing is it's basically kind of generating the models, and then it's learning about what's working well, what's not working well. It's trying different options, and then it's basically sort of over time getting to a pretty good score. So we basically have the sort of validation scores, and we've got the test set scores. And so basically with this sort of balance score that we have basically tries to detect basically potential overfitting. So we basically try to look at how we're scoring across the different sets, and then detect potential overfitting, and then basically penalize models that look like they might be overfitting. Because obviously if we're doing this sort of exhaustive search, we need to make sure that we're not going to overfit, and then we're going to produce really good models. And while this is training, we'll just basically kind of like cover off the leaderboard a little bit. So basically, when we're looking at this leaderboard, we can see all the different models that it's produced so far. We can see that sort of like, so far it's basically obviously produced a bunch of models that aren't that good and some models that are pretty okay. At the moment, the leading model is the decision tree, but if we wanted to filter on specific model types, we can select that model. If we were training on different data sets, we could just basically select which data set we're doing. We can rank it by different sort of like scores to basically see which one is going to basically which metric we might be the most interested in, and now we can see that we've got sort of like just got an XG boost that's come in, and that's basically kind of giving us like a 0.76 which is pretty good. And then basically we can start to explore this model. So we can say, okay, well, across the sort of training set, what are the different scores that we've got? Across the validation set, what different scores do we have? Across the test set, what different scores do we have? We can also then sort of see the sort of the different ROC curves for the different the different classes that we have. And then here we can also see the F1 score breakdown, per class. So we can start to see, if there's any ones that we're particularly, weak at. So, we could see, this consulting, we're not so good at maybe predicting that, but there's actually there's very few examples in here. So actually a lot of what we're seeing here is that, we got a low amount of count or weights against these things. So while we're doing pretty well, again, here sort of like office expense, but there's only 29 examples of that. Rent, there's very few examples of that as well. So, it's basically unsurprising that what we're seeing. We'd hoped is like if we were a larger company with like loads of like millions and millions of transactions, then across all these different buckets, we might expect to see higher results. But even when we do this with really, really large companies, there's always those few straggler accounts which are have fewer examples, harder to predict, and that sort of thing. So basically, we can also just dive into this code section a little bit. So, here we're basically seeing this is the original code that we ran with, and then we're basically seeing that we have like the output here, so we can see, this is how it's handling, like nans, this is how it's handling infinites, that we're actually using sort of like robust scaling, with these different quantile ranges, and sort of like, for these text columns, we can see this one's using sort of TF-IDF, term frequency, inverse term frequency, with sort of like 85,000 max features. We've got a word to vec down here for the reference, and then for transaction we're using glove. So basically you can see it's like really trying out lots of different sort of text encodings for the different parts, and basically sort of like it's kind of using different types of text encoding for the different ones. So obviously different ones are working well in different places. And now we can basically see XG boost and all of the parameters that are sort of like, helping this model work well. And I think one of the things that's quite interesting is like, when we're looking at this across sort of like different size data sets, we often see that really, it's sort of like for you might get these sort of tree-based models do really well on sort of small to medium-sized businesses, but as you start to get up to those really larger data sets, and you're going to see sort of like neural networks take over. And if you're going to have, even smaller data sets again, then the sort of like linear models are going to do pretty good, maybe combined with some of these sort of like, different sort of ways of encoding the data. So, it's really sort of like, a solution like Kortical, which can really sort of find you the absolute best model at every scale of data, is really valuable to basically, being able to just get the eke out the best performance, because we can see that sort of, the difference between, let's say, this decision tree with these sets of parameters versus, this decision tree is really substantial. Okay, and now we basically got a random forest, which is basically sort of performing at about sort of, about 90%. So that's looking, really good. We can just publish this up, and then we can start to explain it. Yeah, here we have these high-level feature importances where we kind of have the reference is interesting, that's coming in. The gross numeric is really interesting. So obviously, like, we can see that there was those generic sort of model invariant feature importances, but how the exact model understands the features can be quite different. But obviously, this might change around a little bit once we kind of get a bit further through here. The other part to notice, like as we're just touching on the low-level feature importances, is that this is really helping us to understand sort of like the ranges of values in the data. So, if you're looking at this from a sort of like a marketing algorithm perspective, then being able to say, oh, people who are less than this or people who are over this. But, like obviously sort of like if we're seeing, like if the gross numeric is less than 925, maybe, for sort of more trivial transactions, they get handled a little differently. So that's helping the model understand it. And what we typically find is sort of like when you're going through these sorts of processes, or these sorts of things with the domain experts, is they really start to buy in. They kind of go, oh yeah, I totally get it. So here we can see that sort of like accounts payable, who is the massive factor that's figured it out. It got that right. Boom boom. So when we basically go back to the model page, we can basically start to view the API code. So this is basically for this best model that we've got, we now basically want to be able to start doing predictions again. So we've got our app, and we're going to do most of it through our app. But this is just to show you sort of like, if you do want to just access the model directly, like from your notebook or something like that, you can just basically like put in this Panda snippet or sort of put in this Python snippet, or basically put in an R snippet, or, even just basically kind of get the raw web request and kind of, work from this. But like I said, we're going to adopt this into our app. So the first thing we're going to want to do is to grab this instance name, which is basically the name that we gave the model when we trade it, where we have all those candidate models appear as part of that. And that basically is the sort of descriptor that we can use to get all the deployments and all that sort of stuff too. So we just go into the config here, and it initially picks up the instance name as the name of the app. We just want to replace that with the one that we got from our data. And then we should be good to adopt the model. Okay, so now we're going to kick off this model adoption process. And what this really is this is now kicking off that superhuman calibration that we talked about earlier. And the superhuman calibration is really that phase again where we said we've got our model that's pretty accurate, but it's not really up at that sort of 97% that we really want to hit. So what we're going to do now is we are going to basically actually you can dive in and you can see all of the code behind how it actually does the superhuman calibration, what it does with the calibration set, the test set, how it actually is going to actually get a candidate model from the UAT environment if it's there, and basically test against that and see if it should publish this new model. So it's basically kind of going to do all this sort of stuff. But we can see that the sort of raw model score that we're dealing with is a 939 F1 score, which is pretty good. So basically that's doing slightly better than we saw in the platform on the test set, which is nice. And then basically this is what's coming out of this is what's coming out of this initial F1 score test, and so then we can see that basically we're getting sort of like a 93% automation rate with a sort of 96% accuracy, so we're like pretty close to that sort of target accuracy that we set, which is really good. And then basically it's saying it should publish, and then we basically get the model is now live. So that's great. So that's all set. So now we've basically gone through, done all the exploratory stuff, basically created our model, and now we're basically we've adopted it into the app. We've got all the sort of superhuman calibration set up. So now we just need to deploy our app. So now we can go Kortical app deploy, and basically what this is going to do is this is going to basically go through the Docker build step, basically take all of the code and data that we've just basically created. It's going to basically build that into a Docker image, and then it's going to let us upload that to the platform. And so then we're going to have our app ready to go with that UI, with everything that we've just set up. And then we're going to be able to play around and check out this bookkeeping automation that we made. Okay, so that's now created our app, so we can grab the URL, head over to the browser, paste that in, and we're going to add in the API key, and we're just going to get that from the config. And boom, we've got our app. Alrighty, so let's upload the test set. So remember, this test set is a test set that was split out. It was never seen during training. It was never seen during calibration of that Superhuman automation. And we can see that it's got 96% accuracy and it's achieved a 94% automation rate. So what we're seeing here is that out of the 2,319 items that we uploaded, 171 of them were automated, and only 148 of them now need that manual review. And then basically for that manual review step, we can just pop down here, we can see this timely accounting. So I'm just going to click anything for this. It will say that's a consultant admin. This one, Cafe Nero, looks like a client expense, so we're just going to click that client expense. And we can sort of see on and on. So we can just really quickly, now we can see that 2 of those have been processed. So we only have to do 148 of those, or this accounting professional would only have to do 148 versus doing all 2,300. And then all of this training that they're doing by sort of doing the ones that the machine learning wasn't sure about, that gets fed back in through that train API that we talked about earlier. And then that updates the model, and the model just keeps on getting smarter over time. So as you can see, it was like, okay, we went a little over a half an hour because we're just explaining everything in a bit of detail, but you can see that you can go really, really quickly from raw data to live model in an app that's sort of doing something, automating bookkeeping really quickly. And this can be applied to sort of, any type of automation. And this service is basically stood up to be able to meet sort of those really sort of enterprise grade SLAs, millions of predictions, millions of volumes. You can work this into, your workflow system rather than basically having to use like this UI, that's got those same API endpoints can be hit by, another service, all that sort of stuff. So, yeah, I hope this has been really useful. If you'd love to find out more, just find us on our website, Kortical.com. Give us a look. We'd love to talk to you. All right. Cheers. Bye.